Welcome students. And the last video I gave the 4 steps method to test whether a given number is a prime number or a composite number. We are going to apply those 4 steps now to check this number 41 is a prime number or not. How to work out this? Very simple. First step says that choose 2 squares so that this number will lie between those two. Clearly 5 square is 25 less than 41. Next 6 square 36 less than 41. 7 square is 49. It exceeds 41. So 36 that is equal to 6 square. Immediate the consecutive means after 6 we get 7. I write 7 square here. It is 49. Clearly between these two our number 41 will be lying between. 41 lies between these two consecutive squares. Here we can say that n equal to 41 for time being. Our n is equal to 41 lies between these two squares, consecutive squares. It is step 1, as I mentioned in the previous video. Step 2 says take square root of each number. Square root of 36 obviously less than square root of 41 less than square root of 49. The value of root of 36 nothing but only 6 we get. You leave this as it is, no need to simplify, and this will be 7. This will be 7. Now what you must do in third step? In third step, check the first number. Clearly it is a composite number. It is not a prime number. So in step 3, we have to list out all primes less than or equal to this number, first number. It is first square root number, as I mentioned in the step, square root number. It is not required, right? First square root number. I am going to list out all the primes, means prime numbers, primes less than, because 6 is a composite number, only less than. If it is a prime number, less than or equal to, you must mention there, less than 6. So what you get here, 2 is a first prime number, less than 6. 3 is a prime number, less than 6. 5 is a prime number, less than 6. Next will be 7, should stop. So we got 2, 3, 5 prime numbers which are less than the first square root number. Step 4, in step 4, see, 2, we write a symbol for divides. If you write vertical line, it is called divides. If I write like this, does not divide. 2 does not divide 41 because it leaves some remainder 1, right? Similarly, 3 also does not divide 41 and 5 also does not divide 41. Fourth step says all these prime numbers should not divide the given number. If no prime number divides the given number, then this is a prime number. If any one of them divides, it is called a composite number. It's called a composite number. Therefore, 41 is a prime. Why prime? Because these 3 prime numbers are not dividing 41. If any one of these divides 41, then 41 is not a prime, it is a composite number. So this is a simple test to decide whether the given number is a prime number or not. We can remember the test name as square root test for easy to identify. Square root test. Square root test. You can remember this word to apply the 4-step mechanism to decide 41. I will give one more example so that we can apply the same thing to decide whether it is a prime number or a composite number, so that you get the clarity about the protocol or the 4-step mechanism to apply for checking a number is a prime number or a composite number. Let us continue other example to test whether given positive integer is a prime number or a composite number. Now here I took one more number, 137. We apply that 4-step mechanism to decide whether it is a prime number or a composite number, a similar manner. So first step is that we have to choose two consecutive squares so that this number will be lying in between them. So for time being, you can choose let n is equal to 137. 137. Now closest the square which is less than this one is 10 square is 100, 11 square 121, 12 square 144. It exceeds. So 11 square, that is equal to 121, and next immediate consecutive number is 12 square, that is equal to 144. You see this number 137 lies in between these two squares. Step 1. Step 2 says we have to take square root for these numbers that I am writing as it is. It is very simple. 11 is a square root for this one. You can leave this one as it is. This is step 3 says, so you see 11 is a prime number here. The first square root number, this is the first square root number is a prime. 11 is a prime. When that is a prime, then what we have to do in step 3, we have to list out all primes, means prime numbers less than, or because we got 11 is a prime here, or equal to, this you must write, equal to 11. If it is a composite number, no need to write or equal to, only less than that number. Clearly what you get here, 2 will come, less than 11, 3, 5, 7, next is 11. Next is 11. Because I told less than or equal to 11. Step 4, we need to check the divisibility. 2 does not divide 137. What about next? 3 4s are 12. It won't divide. 3 also won't divide. Next, 5 also won't divide. You can check this. It leaves some remainder. 7, 7 1 is 7, 6. It won't divide. What about 11? 11 ones are 11. It also won't divide 137. So no prime number is dividing this 137. All these prime numbers were 2, 3, 5, 7, 11. So what is the conclusion? That is a prime number. Therefore, n equal to 137 is a prime. If any one of the prime numbers divides the given number, then it is called a composite number. Be careful. No prime number should divide that number in the step 4. Then only we can say the given number is a prime number. Hope you followed the test how to apply to decide the given prime number. Given number is a prime number or a composite number. Last step will decide. If any one of the primes divides the given number, it is a composite number. Divides any one. One, at least one. Two prime numbers also may divide. It depends on the problem. Here you see, no prime number is dividing that given number 137. That's why 137 is a prime number. Do share, subscribe and like our channel. Next video, we are going to discuss a important theorem called fundamental theorem on arithmetic or fundamental theorem of arithmetic. That is very widely used to compute GCD and LCM using that method. Thank you.